Let's go over question number 2 from the SOA sample questions for exam P. So this is another Venn diagram question, and it's also quite simple. So let's go and read the question first. The probability that a visit to a primary care physician office results in neither lab work nor referral to a specialist is 35%. Of those coming to a PCP office, 30% are referred to specialists and 40% require lab work. Determine the probability that a visit to a PCP office results in both lab work and referral to specialists. So let's kind of break down the question. So the question is that a person will visit a primary care physician, and there's 3 results from that. One result is that they will need a specialist, and the other result is that they would need lab work. And the last result is that they're not going to do either of those. So I promised that this was going to be a Venn diagram problem, so let's kind of draw a Venn diagram. So that's 1. And that's 2. Okay, so one of these circles is going to be specialists. So let's just do spec. And then the other one's going to be lab, because this is all under the umbrella of going to a PCP office. Now, in the first sentence, it says that the probability of a visit results in neither lab work nor referral to a specialist is 35%. So that means that 35% of the time, a person would not be in either of those buckets. So let's remove that. So a person would be in neither of these buckets. So what would happen is that, let's imagine kind of like a box. And the box is 100%. So 100% of the people are inside this box. But 35% of the people are outside of these circles. So this is going to be 35%. Now, we know that, let's see, 30%. 30% is in the specialist box, and 40% is in the lab work area. So what's going to happen is we're going to have to find the combined probability of both of these specialist and lab work areas. So if you remember the probability of a union, the probability of a union is going to be the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So let's break that down. So the probability of A is going to be this whole circle of specialists. So let's kind of draw this red. So, whoops. Let's do that. And let's go with green for the probability of B. So 1, 2, 3. Now, you may have noticed that as I'm drawing this circle, as I'm like shading in the circle, you will notice that this middle portion has been double shaded. So if we go back to the formula, this is the reason why we are subtracting this portion once. This is called the intersection, and that's why we are subtracting this portion once, because we only want to count this intersection once. So that's why it's the red portion plus the green portion minus this middle portion. So we only count it once. So what is the probability of A unit B? Well, we know it's going to be 1 minus 0.35 because everything outside of the circle is going to be 35%. So we only want to know what's inside these circles. So that's going to be 0.65. And that's going to be equal to the probability of A, or the probability of going to a specialist, which is 30%, plus the probability of needing lab work, which is going to be 40%, minus the probability of the intersection. Okay, so let's simplify this a little bit more. So 0.65 is equal to 0.7 minus the probability of A intersection B. So if we just do a little bit of algebra, we find that the probability of the intersection, which is the probability that a person would require both lab work and a referral to a specialist, is going to be 0.05. And that's all there is to this question. So the answer is going to be A. If you like this video, please leave a like. If there's any suggestions or any questions about the solution, make sure to leave a comment. All right, thanks.